All right, so long division review real quick. I noticed a lot of people got stuck on this on the lab. They were just like, why do you put this here? And you forgot all about how to do it, so that's why I put it there. So the first thing is you concentrate on the first terms of both polynomials, and you say what times 3x gives you 6x cubed, and usually that's the part people get right. It's the step after that I worry about. So you put a 2x squared up here, you distribute it down, and you write down the exact answers. 2x squared times 1 is still positive 2x squared. Then group this whole line in parentheses and put a minus out front. A lot of you are trying to skip that step, and where you make your errors is not the first term, it's that second term. You're trying to do two things at once in your head, and usually if you do that, you sometimes do three and change it back to the way it was to begin with. So I suggest writing it exactly like that, and then go through and change the signs. If you have a color pencil or a marker or something, put it in there so that you can see that you actually change the signs. And then just add straight down. So when you add straight down, the 6x cubes are going to cancel, which is what properties? The word cancel. Inverse and identity. So the next two is 5x squared minus 2x squared, better known as?
3x squared.
3x squared. Oh, be careful too with your integers. Remember, if it's same sign, you add the numbers. If it's different sign, you subtract and keep the bigger sign. Some people are still making silly mistakes there. All right, and then bring down the negative 2x. All right. And then you say to yourself, what times 3x will give us 3x squared? 1x. A positive 1x, or just plain old x, that's fine. And then multiply it down, you'll get your 3x squared. Multiply x times 1, you get positive 1x. And you group the whole thing, and you put a big old minus sign out front. I have more people to talk to after class. So, go through and change all the signs. This way, I think. So this becomes plus, this becomes minus, this becomes minus. Okay. And add them up. So we get a cancellation there. Negative 2x minus 1x is 3x. Negative 3x. And then drop the positive 1. All right. What times 3x is negative 3x? Negative 1. Put that up top. Multiply it down. You're going to get negative 3x. And negative 1 times positive 1 is negative 1. And you're going to take this whole thing and subtract it. And then go through and change all the signs. So this becomes a plus, this becomes a plus, and this also becomes a plus. And then when you add them together, you're left with 2. So your final answer is the quotient, way up top there. 2x squared plus x minus 1 plus, it's a positive 2, so I'm going to put a plus here. If it was a minus 2, I just put a minus. And then the 2 over the divisor, 3x plus 1. And that's your answer.
Continue on.
Oh.
Don't let me stop.
Thank you, Queen Danielle. All right, so that's long division. Any problems with factoring? Hopefully you've practiced that enough that it starts becoming a little second nature to you.
Yeah.
That's the one right there. I don't know.
What's that?
That's the one I don't know.
Yeah, long division, I don't know why.
I mean, I know, but I don't.
Too much stuff on
Yeah.
It's a lot of stuff going on, and you got to be really cautious of this line, the green lines. You have to be writing, I'd highly suggest do it exactly like I do. This is probably the only time I say just do it exactly like I do, because this is the way I learned it, and this is the way that I learned not to make mistakes. Putting the parentheses, changing the signs, because I was always one that made mistakes with signs.
You take the first number, multiply it by like 3x, right?
Well, what times 3x gives you 6x cubed?
Yeah.
Yeah, and you put 2x squared up there. So 2x squared times 3x is 6x cubed. And then 2x squared times positive 1 is 2x squared. But then you take that whole thing and change all the signs.
How you do?
Can I do...
I know how to do the cube.
You mean like factoring a perfect cube?
Yeah.
Okay.
125
125
x
cubed
minus 216
216
y cubed.
y cubed 216. I think that's 6 cubed.
6 cubed.
Alright, so rewrite everything as cubes. So this is 5 cubed x cubed minus 6 cubed y cubed.
Parentheses.
Right? Oh, you mean start it? So the first one is going to be 5x minus
Swap.
6y.
Square the first term.
Square the first term because you're going to create that trinomial.
Squared.
So you square that and becomes 25x squared. The next term is the product of the two that you see, 30xy,
Plus.
and it'll be plus because you changed that sign. And then the last thing is square the last term,
That would be 36.
positive 36, and it's always going to be positive.
Oh, that's what hold on.
Because a negative times a negative
I
is
did a
a,
negative, that's
yeah.
why I kept coming up.
it's a negative times a negative is a positive. The only sign that changes is this one. This one could be positive or negative, but that last one's always positive, no matter what.
Okay.
No matter what.
Wow.
And that's it. I mean, it's not a hard thing. It's just you have to get used to the pattern. That's all of it is.
So that's gonna be positive.
Any others?
Why was the middle one
I put a negative.
positive?
No. See, when it's negative here, this sign you change.
Yeah.
If this was plus here, this would be a minus. So if this was 5x cubed, I'm sorry, 5 cubed x cubed plus 6 cubed y cubed, then that first term is going to be 5x plus 6y, and then this is going to be 25x squared minus 30xy plus 36y
So
squared.
no matter what, the last term is always.
Always positive, because you're squaring it. And anytime you square a number, it's guaranteed to be a positive number. Guaranteed.
So the first one will always be positive too then?
What's that?
So the first one will always be positive too then?
What do you mean?
The first
First
number.
term, the 25x.
Oh, well, that one, yeah, that's, because this term's usually positive. And if it's negative, that's just weird. I would highly suggest if this is negative, factor it out or flip it around or do something. Make it a little bit nicer. All right, ready for today, which is really not much different than anything else that we've been doing.
You said go home?
You're dreaming today, aren't you? What's to go home to? It's a miserable looking day out there.
Good days there,
Alright, so today we're going to,
Do nothing.
yeah, go back to solving equations. But this time, instead of solving linear equations, we're going to solve what's called quadratic equations, which are basically factoring type things. Quadratics, of course, are equations whose highest degree is 2. Linear equations, the highest degree is 1. You know, ax plus by equals c, that type of thing. All right, so this basically works on one principle. So this is 5, 8. Yeah, 5, 8. What do they type in that? I'm just curious. Solving equations and applications using polynomials. We'll just call it solving polynomial equations. And the principle that, or the law to use to solve a quadratic equation is simply this. If you have a times b, and the answer is 0, what must be true? One of them has to be 0, because that falls into the 0 multiplication property. Anything times 0 is 0. Then either a is equal to 0 or b is equal to 0. Now you got to think of something. The or means one or the other or both. So either a is 0, b is 0, or they're both 0 at the exact same time. All right, so this is a law that we're going to use to solve polynomial equations, specifically the ones with degree of 2. So for instance, if I have x cubed minus 5x squared minus 6x is equal to 0. I'll give you a golden rule. When you're dealing with a polynomial equation, something higher than degree 1, get it equal to 0. There might be a bunch of junk on one side and a bunch of junk on the other side. Get them all on one side, keep the highest degree positive, and get it equal to 0. That way we can use this property up here, that the product of two things equal to 0. You can just say that the factors are equal to 0. All right,
So you said it was a degree higher than 2?
1. Yeah, we were talking about degree 2, degree 3, degree 4, anything up above 1. Because 1 is linear and you just solve it like you do linears. Get all the variables on one side, get all the numbers on the other side, get the variable by itself. All right, so what can I do to this thing first?
Put 0 in there.
I can pull out an x, so you pull out the greatest common factor, just like regular old factoring, and you get x squared minus 5x minus 6, and this is equal to 0. Are we done? No. Can you factor x squared minus 5x minus 6? Yeah. So factors of 6 is subtract up to 5. 6 and 1. Does anybody know the quick factoring yet?
How you do it?
Well, if you've noticed, you pick 6 and 1, right? And at the end of the answer, you'll have a 6 and a 1.
So it's x is plus 6. It's minus 6.
It's x minus 6 and x plus 1. Now, I highly suggest you only use that, and actually you can only use that when the lead coefficient is 1. This does not work if the lead coefficient is 2 or 3 or something else. What? Oh yeah, I've been making you do it the long way the whole time, yeah. But I was hoping you'd go, oh, wait a minute, I picked 6 and 1 at the beginning. Look, it's at the end. But, you know, that's just pattern recognition. Isn't that horrible? So here I have something like a times b times c is equal to 0. Well, that's just an expansion of this law. If a times b times c is equal to 0, then a is equal to 0, or b is equal to 0, or c is equal to 0. It's one of the three. So you take each one of the factors.
There's somebody out there. Right
There's a lot of people out there. Take each one of the factors and set it equal to 0. Individually. So you get x is equal to 0, the first factor. X minus 6 is equal to 0, the second factor. And x plus 1 is equal to 0, the third factor. Now, again, this technique only works if it's all multiplied together. You can't have something plus something and then set the somethings equal to 0 because they're being added. So one of my answers is clear. X is 0. This one gives you x is 6. And the last one gives you x is negative 1. Now,
Negative 6.
what's that?
Why is it not negative 6?
How do you solve for x? You add 6 to the other side. How do you solve for this x? Subtract 1 to the other side. Also, you could think of it this way. If you yank that negative 6 from the left to the right, it has to change signs. All right, but here's a problem. The answers are in 3 different locations. And eventually, I think in the next chapter, we'll get solutions that don't work. You know, we'll go through all the work, we'll get an answer, and it actually does not work in the original equation. So to be really clear about the solution, we write it this way. This is called a solution set. And when you write a solution set, you're saying, those are my answers. Those are the ones I know that work. And if you want, you can check them out. If you take in 0, of course 0 works, because if each one of the terms would turn into 0. If you take 6, this is, oh good God, 6 cubed, which is 216 minus 36 times negative 5. It does work. You can plug it into your calculator. Negative 1 would work a lot better. That'll make this one negative 1, negative 5, and that one plus 6, and that would equal 0. So you can check them if you want. Not that bad, right? I always found these to be kind of easy. How about this one? This is number 8 out of the book. 4x squared minus 13x plus 3, and it's equal to 0. All right. So the invisible direction here is factor. Get it equal to 0 and factor. So when you say solve this equation, those are the hidden directions. Get it equal to 0, factor what's left over. All right, so GCF? There is not one. No, one, but that's trivial. All right, how do I factor this thing?
Multiply the 4 times 3.
Multiply the 4 times 3. There is no quick way of doing this one. 4 times 3, of course, is 12. What are the factors of 12 that add up to negative 13? 12 and 1. And this one you have to break up into 12x, 1x. What kind of 12? What kind of 1? Both of them negative. They're going to be the same sign because it's add up to. All right, and then bring down your 4x squared. Bring down your positive 3. Set it equal to 0. And then just go through your techniques, which is group the first two. What can I pull out? 4x. What's left behind?
X minus 3.
X minus 3. GCF of the second two?
1.
Negative 1. Left behind?
X minus 3.
X minus 3, because positive 3 divided by this negative 1 will give you negative 3. Second thing is you want those to be the same, but don't force them to be the same. Make sure that they really are. And then finally, yank out the x minus 3 as the greatest common factor. Left behind, 4x minus 1. And it's still equal to 0. I've had people get this far and leave this as the answer. Because in their mind, what they're doing is just factoring, not solving the equation. So down here, we're going to get x minus 3 is equal to 0, and 4x minus 1 is equal to 0. So the first one gives us x is equal to 3. What's the second one give us? A fraction, which is fine. 1/4. You're going to add the 1 and divide by 4. So this will give us x is equal to positive 1/4. And then the final step is to write it as a solution set, saying that 3 is one of my answers and 1/4 is the other. And there you are. Enjoy drawing those little squigglies. They took me forever to learn how to draw, nicely. I mean, when I first did it, it was like this.
That's fine.
And that's fine. I mean, I'll understand it. As long as you don't make it look like a 3, we're okay. All right. Which one? The squiggly? Oh, my artist.
Nah, the whole thing.
Oh, this whole idea of solving? That ain't bad. You say, that ain't bad. And you're like, what? Be specific.
Oh, you shoes.
My shoes. Do they get harder? Yeah. Not really. How about this one? This is number 20. It just looks different. X cubed over 24 minus x squared over 12, and it's equal to x.
Don't give us one of them on that test.
Why? What is wrong with this?
You gotta multiply second by 10 now.
You multiply everybody by
24.
24, the common denominator.
Common denominator.
Remember solving equations, if you have fractions, you multiply everything by the common denominator.
She's echoing.
So we multiply everything by
24.
24. Both sides of the equation. That'll get rid of the fractions. It'll write everything as integers, which is nice. And then we should be able to solve it. So 24 times x cubed over 24 is?
X cubed.
X cubed. 24 times x squared over 12?
2x squared.
2x squared. 12 goes into 24 twice. And on the other side is just 24x. All right, now what?
Subtract out 24x.
Got to get it equal to 0. And you want to keep this highest power positive, because otherwise factoring becomes horrible. So keep this positive, move the 24x this direction. So you're going to get x cubed minus 2x squared minus 24x. And don't lose the equal, and it has to be equal to 0. Okay. Now what? There's a GCF, pick out the x. Left behind is x squared minus 2x minus 24. And that's equal to 0.
Why you didn't do 2x?
There's no 2 here.
There's 2 right there.
I know, but if you're pulling out a greatest common factor, it's got to be in every single term.
Oh yeah, that's right.
You're thinking of grouping. We're not grouping this one yet. All right, factors of 24 that subtract up to 2.
6 and 4, negative 6, positive 4.
Negative 6 plus 4 is negative 2.
Well, that's a little lot, right?
Oh, duh. I was thinking 12. Don't mind me. So factors of 24 that subtract up to 2, 6 and 4. So this becomes x, x and 6, x and 4. minus 6, and a plus 4. And if you want, you can go through the grouping technique, and it will still come up to this answer. The order might be a little different, but that's okay. And then set each factor equal to 0, so we're going to get x is equal to 0, that first one. By the way, this is the one that most people forget about, because they get used to seeing binomials, and they set all the binomials equal to 0, and they forget this poor little monomial sitting up front. So it has to be every single factor. So x minus 6 is equal to 0, and x plus 4 is equal to 0. So one of the answers is apparent. The other one is x is equal to positive 6, and x is equal to negative 4. And our solution set, 0, 6, negative 4. These are all the values of x that make this equation true. Not that bad. So don't let fractions stop you. What else might look ugly? This one. That's not horrible, but I don't have to type out like, 28. 2x squared minus 4 minus 3x equals 4x minus 11. Distribute. You need to get rid of those parentheses. So this becomes 2x squared minus 8 minus 3x, and then the other side doesn't change. Okay, now what?
Get the 4x minus 11 over.
Get everything from one side out to the other, keep the x squared positive, so we'll subtract 4x, and we will add 11. So subtract 4x, add 11. So we're going to get 2x squared
7x, negative 7x,
minus 7x
plus 3.
plus 3. You want to get it in descending order so that you have your x squared, your x, and then the number. If you don't, it's not a big deal. You can do it in the next step. Don't forget the other side is equal to 0. A lot of people are like, oh, it cancels out, it disappears, and all of a sudden it turns into just a factoring problem and not an equation anymore. All right, how do I factor it? 2 times 3 is factors of 6 that add up to negative 7.
6, negative 6 minus negative 1.
Negative 1, negative 7. I mean, negative 1, negative 6.
Negative 1 and negative 6, negative 7. Okay. So this is 2x squared, 6x, 1x, and a plus 3. And you said negative for both of them? Okay. And then, group of factors. GCF of the first two? 2x. Left behind? X minus 3. GCF of the second two? Negative 1. Left behind? X minus 3. Sure you guys don't want the test Friday?
I told you
Friday.
we didn't do it Friday.
They're all voting for Monday.
Oh, my test on Monday.
See? GCF of the two terms that we have left? X minus 3.
We voted when y'all won't hear stuff.
And left behind is
Okay, first one.
2x minus 1. And this whole thing is equal to 0. So, we get x minus 3 is equal to 0, as one factor equal to 0. And 2x minus 1 is equal to 0, so the other factor is equal to 0. Do you see where some mistakes can be made? Where might you make a mistake? Well, right here. What's missing? The equal to 0. You stop right at the equal to 0, and sometimes you don't bring it back. So probably the best thing to do is keep that equal to 0 off to the side so you do not get it. Notice none of you wanted to say it, so I did write it. Did you write it? So the first one is x equals 3, and the next one is x equals, so you get x equals 3 and a half. Well, not 3 and a half, 3 comma half.
Why is it not 0, 1/2, and 3?
Why would it be 0? Well,
Because your code.
why was this one 0?
I don't know, I'm asking you.
Well, how many factors does it have?
2,
3.
3.
This is this times this times this. I mean, literally, this is x times x minus 6 times x plus 4. There's 3 factors, therefore there are going to be 3 answers. And you said each one of the factors equal to 0, so one of them became x equals 0. But over here, there's only 2 factors, and I said each one of them equal to 0, and you get 3 and 1/2. What did I tell you about this poor little x out here? He gets mistreated.
Yeah, it's only gonna be 3 answers. It's gonna be 3 answers when there's 3 powers.
Yeah, but you're getting into college algebra there. But yeah. If you have a cube, you're going to have 3 answers.
How many of powers is
If you have a degree 5, you're going to have 5 answers.
What are you
Kind
gonna
of.
put the 10?
There's a little bit more to it. Have we got imaginary numbers in here?
No.
No, so I can't talk about it.
Imaginary number.
But if we talk about imaginary numbers, then yeah, it's exactly the number of degrees.
I'm having trouble with real numbers.
You haven't read my cartoon up there yet.
So on the test, are you gonna put only the highest power you gonna put might be like 2 or 3?
The highest power will be these 3.
Okay.
I won't go any higher. There's no point in that because the technique is get it equal to 0 factoring. And you can wait until college algebra to deal with the other ones.
Can't wait.
You can't wait. All right, what other things can we do with this stuff? Look at this other page. Looks like word problems to me. Guess what's on the test? Word problems.
word
I did
All
say
right, we'll
that.
see the test on
I
next
think
Friday.
that's just in your book.
It's just in my book. It'll just be on the test too. Just in my book. Word
Oh,
problem.
we got rid of
Can we
the.
say that for college algebra?
What's that?
Yeah.
The word problem.
Oh my God, yes. Even
Okay, well,
worse
it's not
ones.
even that.
Worse than these. These are baby word problems.
Baby.
Like this one. This one's funny. Number 34 on page 295. Number 34. Now, if it was just solving the quadratic equations, yes, I would put the test on Friday. But because there are, well, these on it, I'll put it on Monday because I know what's going to happen. You're going to have questions on Friday and on the lab. So, number 34 says a triangular Boston Red Sox banner has an area of 150 square inches. The altitude of the triangle is 3 times the base. Find the measurements of the base and altitude. This is a problem that goes way back.
It's kind of easy.
How many people, do they even sell those banners anymore? The triangular banners for baseball
Yeah.
teams?
Dependents.
The pennants, do they? See, I used to have them on my wall. So I knew how to draw them, but if you never saw a baseball pennant, you'd have a heck of a time. Oh, that is horrible. I can't draw it on its side. That's the way it's supposed to be facing. We're going to draw it this way. It's much easier to draw. It is this type of triangle. What kind of triangle is this?
A really long one.
Isosceles, where 2 sides of the triangle are equal. Then they talk about a altitude. What's an altitude of a triangle?
I never took geometry.
that thing that goes this way. And how does the altitude have to touch the opposite side?
Left to right.
At what? Say it.
From left to right.
No. Like, if you have this triangle here, this is called the scalene triangle. None of the sides are important. If you start at the vertex up here and you drop an altitude, does it drop in this direction?
Straight down.
Straight down. So how does it hit the other side?
That angle.
What kind of angle?
90.
90-degree angle. It falls down and hits the other side at a right angle. I said what wrong?
You should just stop
Yeah,
going
she
straight
should have
line.
said what angle.
Yeah, because when you training this,
I was trying to get you to say, how does it hit the other side?
Honestly, that's not work.
So if we drop this altitude, it's going to hit the opposite side at right angles. Okay. Now it also says the altitude of the triangle is 3 times the base. Now, the side that it hits, this is called the base, even though the pennant is usually lying on its side, like up here. So the base is where the altitude hits. So if the green line is 3 times the bottom here, which one do I know the least about? The bottom. So we're going to call the bottom x. So this side gets a value of x from here to here. So therefore, the height of this, the altitude of it is 3x. Okay, so we get a 3x here. And this is going up and down. Okay. What else do they tell us about this triangle? Area. How do you find the area of a triangle? Well, it's length times width, I'll give you that. But usually length times width is a rectangle. You know, this is a rectangle. So when you talk about a triangle, you say it's, you don't call it length times width, because that's triangle, or rectangular measurement.
1/2 base.
Base and height. So it's 1/2 base times height. 1/2 BH. It's too much.
I can remember this is way back like when I was in middle school.
Yeah, geometry.
I
Gotta
never
love
took
it.
it.
I'll give you the formulas, that's not a big deal. So area equals 1/2 base times height. If you're rectangle, it's length times width. What other shapes would we have to deal with? I think that's it. Circles, you know, pi r squared and 2 pi r, on things like that. But this one's
Yeah.
easy. Do we know the area of this triangle?
No. Do we?
Yeah, it says 150 square inches.
Oh.
So this side becomes 150 square inches is equal to 1/2 the base,
X,
x, the height,
3x.
3x. Hey, that's not that bad. Alright, how do I solve? Well, I don't like the fraction. Multiply both sides by 2, so 150 times 2 is 300. Is equal to, now 2 times 1/2 is just 1, so then you're left with x times 3x, better known as 3x squared. Okay. What else do you think you can do to this? Divide both sides by 3, so this becomes 100 equals x squared. Now, this is in the polynomial section where we're factoring and all that fun stuff. So we need to get this set up as a quadratic or a polynomial equation. What do I need to do? Subtract the 100, get it equal to 0. So we're going to get 0 on this side is equal to x squared minus 100. And this is one of those problems where you say, thank you, because x squared minus 100 is easy to factor. What's it factor into? X minus 10 and x plus 10. Okay. And then what do we do with the factors? So we get x minus 10 is equal to 0. Therefore, this one is going to give us x equals 10. And take the other one, which is x plus 10, and set it equal to 0. And we get x equals. So what's the answer to the problem? Is it 10 and negative 10? Read the question. 10 and 30. What about the negative 10? You can't have a negative measurement. That doesn't make sense, because where would you go? I'm going to walk negative 10 feet. Now, if you ever get into physics, there is such a thing called negative 10 feet. But it's not really a measurement in negative land. It's just this. If you walk this way, it's positive 10 feet. And if you back up, it's negative 10 feet. But it's still 10 feet. All right, so the answer to the problem is this in inches or feet? This is inches.
Yeah.
So this would be 10 inches by 30 inches. So the pennant is 10 inches on the base and has an altitude of 30 inches. Yay, that wasn't that bad.
Yes, it was.
Yeah.
I just had to teach you a little geometry.
Where did you get 30 from?
Where did I get 30 from? Well, if x is equal to 10, that's the base, right? Then the altitude is 3x.
Oh.
3 times 10
Okay.
is 30. So it has a base of 10 and a height of 30. 36 is the same thing. 38? 38. 38 is dealing with rectangle. The area of a rectangular mouse pad is 480 square centimeters. 480 square centimeters. Even though you write cm squared, it's read square centimeters. You kind of read it backwards. its length is 16 centimeters shorter than twice its width. Well, I need to draw a mouse pad. Here's a mouse pad. What do I know the least about? The length is 16 centimeters shorter than its width, and then twice its width. Which side do I know the least about? The width. So I'm going to call the width x. Now I don't care which side you call x, but most people consider the width left or right, or horizontal. All right, therefore the other side must be what? Its length is 16 centimeters shorter than twice its width.
X minus 16?
16 minus it.
Okay, let's read it again. Its length is 16 centimeters shorter than twice its
16
width.
minus 2.
Is it 16 minus 2x? Or is it 2x minus 16?
Yeah, 16.
Okay, well think of it this way. Its length is 16 centimeters shorter than 5. No, that wouldn't make any sense, would it? Because then you would have a negative number. So this side has to be 2x minus 16. It's less. 16 centimeters shorter. Okay, so what's the formula that pertains to this picture? Well, this thing up here is considered area. An area of a rectangle is length times width. You can also say base times height if you want, but most people stick with L and W. Do I know the area of this thing? 480
Square centimeters.
well, square centimeters, but leave that off for now. Do I know the length of this thing?
X. Oh, 2x minus 16.
2x minus 16. And do I know the width? X. And there we have a nice little quadratic equation. Danger number 1. I've seen people do this. 2x minus 16 equals 480 and x equals 480. Is that true?
No.
No. The only thing that can work is if it's equal to 0. It has to be 0.
So it's 2x squared.
Yeah, get rid of the parentheses. So this is 480,
16.
2x squared minus 16x. Then what?
Subtract the 480 over.
Move everything towards the x squared, keep the x squared positive. So it becomes 0 is equal to 2x squared minus 16x minus 480. Okay. What should you do next?
Take out the 2.
Now, here's a cool thing about equations. Do you want to take out the 2? Do you want to factor it out?
I don't know.
You can. You can. And if you pull out 2, you get x squared minus 8x minus 240. But there is another option because we have an equation. Well, actually, I can divide. The trick is this. If you divide this entire side by 2, what else do you have to do? Divide the other side by 2. You can also factor it out, but then you have that 2 sitting up front, and it kind of gets in the way. The only danger of this is, if it was 2x cubed minus 16x squared minus 480x, you cannot divide by 2x. Do you know why? Why can't you divide by a variable you're trying to solve for? Well, you'd be solving for it. You'd actually get some of the answers, but there is a possibility that I erased it already, that x is equal to 0, and you cannot divide by 0. So the golden rule of solving equations is never ever divide by what you're trying to solve for. Because if you do, that's what you're solving for might be equal to 0, and you're creating a contradiction, an impossibility. So the only thing you can divide both sides by in an equation is just numbers. It's the only thing you can touch. So 0 divided by 2 is? 0. 2x squared divided by 2? Remember, we have to distribute this thing. Negative 16x divided by 2? Negative 8x. And negative I'm sorry, give me the answer. Negative 480 divided by 2? Negative 240. And then you get a nice simple equation. But again, do not divide by variables, ever. Unless it's other ones that you're not trying to solve for. So, factors of 240 to subtract up to 8. I can't think of them off the top of my head. So, off to the side. 1 and 240. 12 and? Negative 20? Yeah, that sounds about right. Yeah. So this is going to factor into x12, x20, and that'll give you 240. X plus 12 and x minus 20. And then you just solve. So we're going to get x plus 12 is equal to 0, therefore x is equal to negative 12. Eventually you'll skip that step and just jump right to the answer. And the other one is x minus 20 is equal to 0, therefore x is equal to positive 20. Okay. When you're dealing with a word problem, always go back to the words, the question. What is this thing asking for? Well, it says, what is the length and width of the mouse pad in centimeters? Okay. Which answer do I ignore completely? The negative 20 doesn't, or the negative 12 doesn't make any sense. So the only answer we're going to concentrate on is 20. So we have to take the 20 and plug it back in. We have to see what the length and width is. So if x is equal to 20, what's this side equal to? Well, 2 times 20?
40.
40 minus 16?
Yeah,
40 minus 24. 24. So this is 20 centimeters and 24 centimeters. So for question A, I would write 20 centimeters by 24 centimeters. The time sign here is read by. It's the length and the width of, well, in this case, a mouse pad. All right, what's B say?
What are the length and millimeters?
What are the length and width of the mouse pad in millimeters? How many centimeters in a millimeter? 100. So I have to just multiply this 100?
None. No centimeters gonna go millimeters.
No. If you have a centimeter, how many millimeters are inside of it?
You said how many centimeter or millimeter?
How many centimeters are in a millimeter?
Like millimeters are in centimeters.
0.01. You can always convert one way or the other. All right. So how many millimeters are in 20 centimeters?
A lot.
It's 10 millimeters for every centimeter. So this would be 200 millimeters. Yeah, because it goes milli, centi, deci, base, deca, hecto, kilo. All right, 200 millimeters by 240. You say 2,400, that's 2,000 more. And that would be part B. I wrote centimeters.
Good question.